Hello everybody, so in this video we're going to continue talking about antiderivatives and we're going to look at a couple more examples of finding the antiderivative. Okay, so let's look at our first example. Okay, so we're still looking for the most general antiderivative, which means we're going to have the idea of adding that constant that we don't know what it is. Okay, so let's look at our first one here. Okay, so remember when we have a power function like this, right, we're going to be using the idea of the power rule, right? So we know that the exponent is going to be one larger here. So that would be 7 over 5. Okay. And then when we do that, right, we want the answer to be 7, right? So if we're looking at something where we take the derivative here, right, we know we're going to have 7 times whatever number we put here times 7 over 5, okay, and this should be equal to 7, right? So the reality is that we want this number to cancel out the number coming from the exponent, right? Just like we saw in the previous examples. Okay, so really what we want to do is to use the 1 over 7/5, right? Or the reciprocal of 7/5, which is 5 over 7. Okay, and we're going to use the exact same trick here, right? So if we're adding 1 to the exponent, right, negative 4/5 plus 5/5 is 1/5. Okay, and then we want to use the reciprocal of the exponent, which would be 5 over 1. Okay, so if we simplify these a little bit, right, and not forgetting our constant, okay, this 7 will cancel with this one, and I get 5x to the 7/5 plus 8 times 5 is 40x to the 1/5 plus c. Okay. Right, so when we multiply this exponent with 5, we're going to end up with 7, which is exactly what we want. 40 times 1/5 is 8, which is exactly what we want. Okay, so we can use that rule that we looked at in the first video, right, where you use 1 over the exponent or the reciprocal of the exponent. Okay, so let's look at this one. Okay, so let's look at the antiderivative here. Okay, so remember, for sine, the antiderivative is negative cosine. So we're going to have negative 2 cosine x, right? And we just have to remember that the derivative of tangent is secant squared. We have to recognize secant squared as the derivative of tangent. So the inverse, or right, I'm sorry, the antiderivative is going to be tangent x. Okay, and then we have our plus c because again, the constant doesn't affect the derivative. Okay. So these are really ones where we are using the power rule that we talked about in the first video, or we are recognizing the antiderivatives of the trig functions, okay? Now let's talk a little bit more about if you have to do some more work to find the antiderivative. Okay. So let's look at what if our function is a little bit more complicated. Okay, so the best thing we can do here is simplify this before we look for the antiderivative, right? So this is just the original function. So this is 1 over root x plus x squared over root x plus x to the 4th over root x. Okay, and we know that square root of x is really x to the 1/2, right? So this is 1 over x to the 1/2, right? This is x squared over x to the 1/2, and this is x to the 4th over x to the 1/2. And then we can use our exponent rules to simplify each one of these, right? So this is x to the negative 1/2 plus x to the 4/2 minus 1/2 is 3/2. And here I have 4 or 8/2 minus 1/2 is 7/2. Okay, so after that, after we have completely simplified the function, then we will look for the antiderivative. Okay, so again, for these power functions, I'm going to be adding 1 or 2 over 2 to the exponent. So this is going to be positive 1/2. And then to counteract what happens when I multiply by 1/2 to take the derivative, I'm going to multiply by the reciprocal, or 2 over 1. Okay, so same thing here. I would have 2/3, oh, I'm sorry. My exponent would be 5/2, and I would multiply by the reciprocal, 2 over 5. Okay, here my exponent would be 9/2, right, because I'm adding 1 or 2 over 2, and I would multiply by the reciprocal, 2/9. Okay, and then I still need my constant. Okay, so that's one trick to doing a more complicated antiderivative. You can always use tricks to simplify it before you even start thinking about the antiderivative. Okay, let's look at one more example like this. Okay. Now, when we look at the antiderivative for x squared, right, we know that we are going to use the same rule that we used with the other power functions, right? So it's going to be x cubed, and then to counteract the 3 when we take the derivative, we're going to multiply by 1/3. Okay. Now, when we look at this, I want to remind you guys of what we were talking about with the inverse trig functions. Okay, so in the first video, we remembered that the derivative of sine inverse is 1 over square root of 1 minus x squared. Okay, but it is also the case that the derivative of cosine inverse, okay, is minus 1 over the square root of 1 minus x squared. Okay, so we really have two different choices here. Okay, one choice is to look at this as minus 3 times 1 over 1 minus x squared. Okay, and if we do that, this is going to be minus 3 sine inverse of x. Okay, but if instead we see this as plus 3 times negative 1 over the square root of 1 minus x squared, okay, then this would be, this part is the same. We would have plus 3 times cosine inverse of x, right? And these would absolutely give the same derivative, right? Because the sine inverse would give you positive 1 and you have the negative here. The cosine inverse would give you negative 1 just from the derivative itself. Okay, so these are both correct antiderivatives, even though they look different. Okay, well, that is what I wanted to show for those little more complicated type of general antiderivatives. Now let's look at an example where we have some additional information. Okay. 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 So here, if I look at 1 plus 3 root x, again, I personally would simplify this to the exponent version of this, which would be 1 plus 3x to the 1/2 power. Okay? Now, if we are looking for f of x, when we have f prime of x, we are looking for the antiderivative. Okay? So f of x would be x, right? If we take the derivative of x, we get 1. So the antiderivative of 1 is x. Okay. Plus 3. Now if I add 1 to the exponent, or 2 over 2, this is going to give me 3/2, right? And I want to multiply by the reciprocal, or 2/3. Okay. So when I simplify plus my constant, when I simplify that coefficient here, I'm going to have 2x to the 3/2 plus c. Okay? Now, in general, with this information, that is all I could do. But if the problem gives you some other information, which this one does, it says f of 4 equals 25, okay? Now we are ready to use that information. Okay, so let's look at this. F of 4 equals 4 plus 2 times 4 to the 3/2 power plus c. Okay, now we do want to evaluate 4 to the 3/2 power. So the square root of 4 is 2. 2 cubed is 8. Okay, so I would have f of 4 equals 4 plus 16, or 20 plus c. Now I do know that this should be 25, right? So this tells me that c equals 5, okay? So I can go back to my original antiderivative, f of x, and say that f of x equals x plus 2x to the 3 halves plus 5, right? So I can find the most general antiderivative, and then if I'm given some other information, which is often called initial information, then I'm able to actually find my constant c. Okay? Let's do another example like this. Okay, so let's start by finding the antiderivative here. Now the antiderivative of f double prime, or the second derivative, is only going to be the first derivative, right? The antiderivative is something whose derivative is f double prime, right? So this is going to be the first derivative. So the antiderivative of sine is negative cosine, okay? And the antiderivative of cosine is positive sine, okay? And then I have my plus c. Okay, so now I'm going to use this information that I have, this f prime of 0 equals 4. So f prime of 0 equals minus cosine of 0 plus sine of 0 plus c. Now cosine of 0 is 1, and sine of 0 is 0. Okay? And f prime of 0 should be 4. So I have negative 1 plus c, or c equals 5. Okay? So I'm going to go back to my first derivative, f prime of theta, and put in that c was 5. So I have minus cosine theta plus sine theta plus c, which is 5. Okay. So once I have the first derivative, right, when you look at the question, it says to find the original function, f of x. So I'm going to find the antiderivative again. Okay. So again, the antiderivative of cosine is just sine. So this minus sign is this one. Okay, and the antiderivative of sine is negative cosine. Now, if I want something whose derivative is 5, right, 5x is what has the derivative 5, right? So if you just have a number, the antiderivative is going to have that number times x, okay? And then I do have my constant c. Okay. Now I still need to figure out what c is, so I'm going to use this f of 0 equals 3 information. So f of 0 equals minus sine of 0 minus cosine of 0 plus 5 times 0 plus c. Okay? So sine of 0 is 0. Cosine of 0 is 1. 5 times 0 is 0 plus c. So f of 0 is supposed to be 3. So I get that c is 4. Okay, so I'm going to go ahead and go back to my original function, f of theta. So I have minus sine theta minus cosine theta plus 5x plus 4 as my original function. Okay. This is the example that I wanted to show for this video. So in our last video for section 4.9, we are going to look at a more applied example that has to do with physics, and I will see you guys there.